So now that we've gone through the contract, let's go actually run the demo and take a quick look because it's pretty cool. So let's actually do what's called a test deploy. So this is actually going to compile and run the contract itself. And I'm gonna have to boot up my server here for the tests even to run, I think. So I need my Node.js server running. So why do I have a server in this example? It's a very, very simple Node.js server, and it's simply just managing the adding of the guest key to the contract. So remember, I own this contract. I am the application. I am the NFT. I'm the NFT contract. So I'm the NFT. I'm both the NFT minter and the marketplace. So I can't give away my public key or have my public key be on the front end of any code. So I have to, when I add guest accounts, I have to make a decision. Is this person a real human, and should I give them 3 chances to mint an NFT? That's the first decision. The second decision is, how do I add their key, their public key, to my contract, but without letting them see my private key. So I can't do that on the front end. I have to do it on a back end. Okay. So let's take a look at those tests. So we just did a test deploy. What is a test deploy? It's all the scripts are here in package.json. So I'm not trying to hide anything. Whoops, that's for the server. Let's close that. It's in package.json in the root of the project, not trying to hide anything. It just super simple. You call yarn test deploy, which calls yarn dev deploy. Okay, so what is yarn dev deploy? Well, it's up here. What we're going to do is we're going to build the contracts. Now you can just assume that it builds the contracts, but it does run this build.sh script in here. Then what we're going to do is we're going to remove the near dev folder. We get rid of this near dev folder that has our dev account in it. And why do we do that? Because we want a new dev account. So when we remove that and then subsequently next call dev deploy, then what we're doing is we're going to create a new near dev folder. We can actually watch this again. It doesn't matter. These dev accounts are free. So did you see near dev go away and then come back? So we deleted our near dev folder, then called near dev deploy, which gave us a brand new, fresh dev account. This is the account here. This is our dev account. So it's like dev account A. Okay, so this is us. We're testing, and we're just going to get a brand new account and deploy the contract to that account. And then what we're going to do is we're going to call yarn patch config. This is just a little utility. What it does, all it does really is take the dev account name out of here, and it writes it into our source config.js file. So it takes that dev account name and it writes it in here. And that's because we're going to need it later for all of our tests and apps and all sorts of stuff. So that's it. We patched the config. Now we come back and we run yarn test. What is yarn test? Well, we set the React app environment variable to developer, and we run jest app.test.js. That's it. So what we're running here when we run the app test is we're running app.test.js. Now remember, we just looked at the contract. I told you that we were having trouble with the unit tests, so we don't really need to look at them. So now we're going to look at the app tests. Okay? So why do I call them app tests? Because it's going to test the basic functionality of the app, and it's going to make sure that we basically can test out all of these functions. First, though, I promise you a demo of the app. So let's go and do that right now. Yarn start. So we're booting up here, and we're just going to demo the app. So I have a key from before, but I'm going to have to delete my local storage because I was using this app before. So what I'm going to do is I'm going to sign in as the guest account. So right now what's happening is the Node.js server that I talked about before is adding a key pair to me as an account. Oh, no, it's not doing that. It's because, okay, this is where it gets weird. You see how the Node.js server booted up with this account? This account is not this one, right? 781, 903. Uh-oh, okay. Now watch, we have to just reboot the node server, and we've got 4781, 4781. Okay. So you always want to make sure if you have an app, if you have a server, if you have Jest tests, they all should be referencing the same dev account. Okay? So you just got to keep the dev accounts clear. We're going to sign in as a guest. Now it's going to my Node.js server and getting me a key to the right account. Okay? I have this formatted to kind of simulate like a phone so it looks all cool and mobile. But you guys can also see the console. Okay, so what we're going to do is we're going to use our free mint. So we're going to go to Giphy. I hope there's nothing bad on there. Oh, this guy looks cute. All right. Okay. Not exactly what I thought. Maybe this. Okay, so we're going to take the GIF link and we're going to go back into the app and we're going to mint. And yes, there's no decentralized storage, no nothing. We're just burning this URL into the blockchain. So we're going to go mint. And now we're using our guest key to actually create an NFT in the contract. So we just called the guest mint function. Okay, cool. So we checked our guest mint limit. And look, we actually used up one of our free mints. So we're on the second out of the third free mint. So when we do it 2 more times, we won't be able to do it anymore. So we do it 1 more time, we're 3 out of 3, and then 1 more time after that, and after 3 out of 3, and we can't do it anymore. So if I look at my tokens, I see I have this little cool guy here. Okay? I don't know, it's like some robot scientist thing. So I'm going to set a price of 5, and I'm going to sell this token. That's me using my public key. So again, just like in this diagram, I'm using my public key to call methods of this contract. The contract is sponsoring my storage of the NFT, and that's it. But I'm trying to basically earn some money because, look, I just landed on this app. I've never used this app before. I'm trying to, make some money and kind of get, get my place in the market. Okay. So I go back to market. These are the test NFTs that were created. Look at my token. Price is 5. Okay, everything checks out. Now I'm going to sign out. First, I'm just going to check my config file. Make sure. I'm not on the localhost wallet. Now, the only reason I'm going to switch to the localhost wallet is because I'm going to show you something really cool that will happen on mainnet. So let me just add wallet to, you can do this yourself if you want to. You can run the wallet locally and set up the funding thing, but just wait a sec. So I just had to add that to my project, and then I'm going to launch it. But I have a port problem. Exit out of this one. Oh. I'm going to run the wallet now, locally. Okay, so that's running on 124. And now I'm going to run the app again. So there's the wallet. Okay, I'm going to get out of that. I think I have to do the NFT thing all over again because, yeah, so I have to sign in as a guest again. Oh boy. Because my my key pair, remember my guest key was stored under a different port. So it's like the local storage rules, every local storage. So local storage local host 1234 has a different local storage than local host 3000, for example. So anyway, I'm just going to really quickly, it's a good thing the blockchain is fast. Wink. Okay, so I'm going to mint another NFT. And I'm going to go to my tokens. I'm going to set the price to 5. And now that I'm connected to the localhost wallet, yep, I should be able to sign out and connect wallet. And now I'm going to the local wallet. And oh, I do not have a wallet account connected anymore because I think I wiped out my local host. Okay, I am going to just stop my screen capture for a sec. How do I do that? Hotkeys. I know I programmed it somewhere. I didn't program it anywhere. Okay, I can't do it now apparently. I know what I'll do. Okay, I got a funny background for you. There you go. Okay. You can all look at that for a second. I'm just going to go to my email. I'm going to get a... I hope that worked. I'm going to get one of my trusty testnet accounts. Please bear with us. We ask that you bear with us. Okay, I think I'm out of the woods. Let me just make sure by actually recovering the account. Okay, up so like. All right, okay, and I will move this image down and we're back. Oh, hi. Okay, so I'm logged into my wallet now. So that's great. And now I just have to go and ask the app to redirect me again. So go back. I'm going to go back to where it says connect wallet. So remember, this new, weird little dude here, meditating, is on sale for a price of 5. So I'm going to connect the wallet. I am going to connect si1.testnet. So I'm going to allow that. And now that I have NEAR tokens, so if you look at my wallet, I'm a baller. I got NEAR tokens. I'm going to purchase this little guy. And we're going to transfer. So transfer 5 NEAR tokens. Sounds good. So I'm going to do that. Okay. So now I'm logged in as si1.testnet. If I go to my tokens, I actually own this little guy right now, and there's no price set. Remember, the price got reset. So if I look, my wallet balance actually went down a bit. So if I sign out now remember, in my local storage for this particular URL, including the port, because I messed that up earlier, I can sign back in as a guest. And if I go to my tokens, I don't have any tokens. But if I go to the market, I see that my token sold. So my token sold, so where's my money, right? I mean, I just have this key, I just have this public account, so I don't have any NEAR tokens. So I click on this face and I see, oh, I have a balance of 5 NEAR. So what can I do with 5 NEAR? Well, I can make myself a NEAR account. So I go to the wallet, which right now is running on localhost, but only because I have set it up to use the mainnet funding flow. So I can create a new account. So I can, and what I mean by mainnet funding flow is just that you have to pay NEAR tokens to get a proper account ID. Okay, so what can I do here now? I can do, I can make a testnet account called Meow1. Okay. So I'm going to just do a recovery phrase. I'm going to copy the phrase. I'm going to continue. It's asking me for word 7. I'm going to paste it in here. You should not do this. 12, 11, 10, 9, 8, 7. Okay. Verifying complete. So now it says fund your account. So where am I going to get funds? I mean, I don't want to go to an exchange. I don't want to fund it with my credit card. I'm just some kid. I just made some NFT. I just want to have fun. So I copy the funding address. I go back to the NFT app. And remember, until this point in time, I have never seen the Near wallet. I've never set up a Near wallet. I haven't done anything. All I did was upload a URL and sell it. So pretty cool. So then I put in that funding account and I fund it. I fund it with the 5 Near tokens. And now that the balance is 0, I think, okay, well, what's the deal? So I go back here and it says, whoa, account is funded. Well, that's pretty cool. So now I'm going to go and I'm going to get rid of the funding account, which is totally normal because this was just a temporary account to fund. And I'm going to basically create the account meow1.testnet. Okay, I acknowledge. So there we go. So we should see the account get created. All right. So there we go. So now meow1.testnet, I can sign out, I can connect a wallet, and what can I connect? I can connect meow1.testnet. I can allow that. So remember, I did not have any Near tokens. I actually just basically created something in an app without having to do anything. No wallet setup, no nothing. Just click a button and say, I want to sign up. And I created something valuable that someone else purchased. And that is called progressive onboarding. So meow1.testnet. All right, cool. So now on to explaining the application tests. So remember those JavaScript tests that we had before? Oh, you don't want to see my streaming setup. Remember those JavaScript tests that we had before? And they all passed with flying colors. So we're going to look at those in detail really quick so that you have a better understanding. I'll just make sure this is all set up properly. Yep. We're going to make sure that this is all set up so that you have a proper understanding. We're going to go through the tests. So there are a lot of little helpers that are here for you, for your benefit. But it's important to know where they come from. So if you see things like test utils or near utils, you probably want to investigate kind of what's going on there. You shouldn't typically have too much trouble with them, but it's important to know like what's going on. So they are just right here in the same folder. Here's a bunch of test utilities. So these are just helper functions. So they're just a bunch of functions that will help you basically run your tests and simulate an application environment. If you read through the tests here on the right-hand side, you see stuff like, contract hash, check create owner, check create as guest, check transfer from implicit account, check transfer from regular account, check set price. So basically, those accounts are basically those tests are super helpful to test the full application flow. So what we're going to do when we get started, this font might be too small for you, but that's probably better. Okay. So what we're going to do is we go through, sorry about the contract run through, small font, but that's okay. What we're going to do is we're going to run through the smart contract here. So basically, we have some metadata that we're going to use as sample metadata. We need to create an account for Alice, an account for Bob, and an account ID for Bob, and we need to store Bob's token ID. So we're going to basically create Alice as a full wallet account. So like my si1.testnet that you saw me use. We're going to create Bob as a guest account. We're going to keep track of Bob's account ID and Bob's token. And that should let us do everything we want to do. So before all the tests get started in this, it's actually just like a single run here. Before all of these tests, we are going to create the Alice account and we're going to initialize the contract if it hasn't already been initialized. That's the contract.new that you saw before. So first, I like to test the contract hash just to make sure like everything's running okay. So we make sure that the state code hash for the contract account, and that is just a new account with the connection that we're currently on. So in this case, testnet and the account name. You just check the state to make sure that the code hash for the contract or that account is not equal to this, which is like empty. So it's like no code deployed to the account. The next, we're going to check create for the owner. So basically, it's not really the owner, but it's just like create normal account, whatever. So that's creating a token for Alice. So we're going to mint token with Alice as the owner, and we're going to pass in the metadata, and we're going to pay. Remember, it costs Alice to pay, so she has to pay for this token. And we're going to parse the near amount, and that is going to equal the one near that we have to pay inside the contract. So that is the mint fee here. Okay, so Alice mints the token, and then we expect that the token owner ID is Alice's account ID, and the metadata is the same. Now we're going to check creating as a guest. So here is where we start to do a little bit of public key magic. We sort of do the key pair. We get a random key pair. We are going to store the public key, and we're going to store it in this variable here that's part of the test here. Oh, no, we don't do that. Okay, because I got rid of that. I don't think we use that anywhere. So I'm just going to get rid of that. But what we do is we store Bob's account ID here. Now, how do we get Bob's account ID? Well, remember what I told you about the implicit account IDs down here, where we're checking the owner to make sure it matches the account ID? Well, we're also going to do something similar here to getting the hex of the public key. But here what we do is we take a buffer and we fill it with the public key data, which in JavaScript it's only going to be 32 bytes, so we don't need to slice off the first byte. And then we're going to take that to hex. So we're going to actually convert this buffer to hex, and that's Bob's account ID. So these implicit account IDs, by the way, it's important to note they should always come out to be equaling 64 characters long. Always, 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 always 64 characters long. Okay, now this part, contract account add key, this is typically done on a server. So this is a good time to maybe show you. This is the only part of the Node.js server I'm going to show you. You can go poke around. It's not that crazy. The Node.js server has a method called add key. And here you'll see it's doing the exact same thing. Contract account, add key, public key, contract name, access key methods, change methods, parse near amount. So what are we doing here? Oh, here we're calling contract methods, change methods. On the server, we're calling access key methods. That's just a minor discrepancy about which methods we think that we should be allowing the access key to call. So we have contract methods and we have access key methods. I'm really just demoing the fact that you can scope an access key down, those pop-ups. I'm really, okay, settle down. I'm really just demoing the fact that you can scope an access key down to a different set of methods than any other key. So you can actually have a bunch of methods in your contract that are like, let's say you wanted to make some sort of escrow or smart wallet. You could have a bunch of methods that would allow someone to transfer 50 near, allow somebody to transfer 100 near, allow somebody to transfer 150 near. And you could give people access keys based on those certain denominations and tell them that they can only call those methods in the contract, which would basically be a nice way to permission the smart contract. Okay, so back to it. So now that Bob's key has been added to the contract account, so let's go back to our drawing here once more. Bob's key has been added to the dev account. So remember, Bob's key was just floating out here, and then what we did was we just added it to the account. So now it's part of the account. And now Bob, what we do is we create an access key account. So this is a special helper method that I wrote here. I think it's in here. Nope, it's in test utils. Create access key account. All it does is it sets the current signer for the current network to be the key that we want to use. So basically now, Bob, this Bob account is going to be the current signer of the contract transactions. So then we get a contract instance. So we get an instance of a contract with Bob as the signer. And then we basically call contract Bob guest mint. So this is Bob minting as the guest account. So remember, Bob is just a key attached to the guest account. And we pass in Bob's account ID. Bob's account ID is what? It is the implicit account ID. Okay, so now we go call token data, get token data, and we check to make sure everything's equal. Now this is where it gets interesting. Check transfer from implicit account. So contract Bob, remember Bob, the public key account or the access key account, right? This is Bob. Bob is able to get a contract instance, so an instance in JavaScript of this dev account, and Bob is able to call transfer. And why can Bob call transfer? Well, let's look at the transfer method. Bob can call transfer because self-only owner takes in the token data owner ID, okay? And if we look at self-only owner, it's this method here. The token account owner ID, remember, is the owner ID is the implicit account ID, Bob account ID, the one that we created here, but from the hex of the public key. And now connecting all the dots, we check that the signer is the current account ID, but it is not. So this dev account ID does not equal the account ID from, this is the implicit account ID from the public key, okay? So this dev account A does not equal this implicit account ID. So we have failed this first test. But now we're going to check if the implicit account ID matches the token owner account ID. And then if they do not match, we will panic and say, blah, 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 you're trying to do something that doesn't belong to you. And then that's it for Bob. But it's not it for Bob, is it? Because Bob actually is the public key that maps to the implicit account ID. All right, cool. So now we're going to get the token data and we're going to check that the actual owner now of the token data is actually going to be Alice because Bob gave his NFT token to Alice. Okay, cool. So now we're going to check transfer from a regular account. So Alice now has the token, by the way. So check transfer from a regular account. So now we go get contract Alice. What is contract Alice? It is an instance of the contract account or the contract instance in near API.js, so a contract object. And it's actually has Alice signing the transactions now. So Alice will now sign the transfer action, and she's going to transfer it back to Bob, and she's going to pay the gas. Okay, so now we check the owner, and the owner is Bob. Okay, cool. So we're getting along with these tests here. Now we check set price from implicit account and purchase from regular account. So contract Bob is going to set the price. Contract Alice is going to make the purchase. The price was set at 1 near token. Then we're going to check the contract data and make sure that Alice is the owner. And now we're going to check withdrawing from the implicit account. So that was, by the way, that was the purchase, the big purchase. And now Bob's implicit account ID, remember, we go back up here, Bob's implicit account ID here, account to proceeds, Bob's implicit account ID has a balance of 1 near. And Bob is going to call withdraw. And he's going to say, I am withdrawing from this account ID. I'm signing with some key. I'm withdrawing from this account ID and the beneficiary is this account. And so they can be the same. So let's look at withdraw here. Okay, so we're just going to double check all that. And remember, this is calling self-only owner on the account ID. But in this case, we're not checking the token owner. We're checking that the account to proceeds account ID is, in fact, the one that is owned by whoever is signing the transaction, whether it be the signer account ID or the signer public key that matches the implicit account ID. Okay? With me? All right. So at long last, we can go get the account, we can get the state of the account, and we can check that the state amount, so this is like the balance of the account, equals 1 near. That's it. That is how Bob got 1 near in our application test. And that's exactly what you saw me do in the app example earlier. Next, we're going to check the minting limit, and we're just going to make sure that Bob cannot mint over the limit. So if Bob did mint over the limit, we would expect, and we would false here, so we would basically fail this test. But if we catch an exception, which is a contract panic, we warn about it and we expect true, and that is the warning here. You'll see panic at, no, wait, not there. Smart contract panicked. No, it's not there at all. Missing field metadata. What? Oh, it panicked for the wrong reason. So I'm actually going to fix this test now. Cool, cool. Okay. So we're going to run yarn. Oh, we're not going to exit that server. We're just going to run here yarn test. We're going to run yarn test. Now, yarn test is different from yarn test deploy. It's just going to run the test on the JavaScript, but without redeploying the contract account. So when I go back to the app, everything should still be the same. So let's see why the contract panicked. It should panic because Bob's trying to mint more than it's allowed to. Okay, everything failed. That's weird. Transaction has expired. I'm going to run that one more time, but I didn't really change a lot on this contract, so for this test. So let's see. If this doesn't work, I'll just come back to it later. I want to talk about the app for a sec and the different components in the app, just the front end side. Should work. I don't know. Let's see. A little different this time around. Ah, okay. So they all passed, but why is the reason that the mint limit test failed? Because the smart contract panicked because it's out of free mints. Okay, so that worked.